Hello, hello. So, to multiply, we can either think about kind of like foiling it or using a rectangle. Either way, you should end up with 6 minus 3i plus 2i minus I squared. So that's going to simplify to 6 minus I minus -1, right? This turns into -1. So 6 minus -1 will be 7 minus I. Woo! Goodbye, pen. Okay. Got it. Questions on that one? Oh, also, why does it make sense that the result is complex?
Because there's an I.
True, but there is something that we could have multiplied by 3 plus I to get something that would be real. What would that have been?
3 minus I.
There we go. Yep.
Let's go.
So the result, it has to be complex. Because they're not conjugates. I don't have room to write that. I'm going to write not conj. Because the only way to get a real result would be to multiply it by its conjugate. For this next one, we can set up an equation. Y equals A times x plus 2 times x plus 4. And then which one of these, or any of these, going to get a exponent?
Shouldn't that be x minus 4?
What did I write?
You're x plus 4.
Which one of these should have an exponent?
X.
X. And it should have an exponent of?
2.
2.
It's a doot.
Doot.
Yep, because we got that doot going on. Baby parabola happening. That's kind of a weird way to write it. We'd usually write it y equals ax squared times x plus 2 times x minus 4, but it doesn't really matter. And then we want to solve for what a is. So we're going to plug in 1, -18.
What? Wilson didn't eat yet.
Sorry, that was my mom.
It's okay, it happens.
Sometimes people do have moms.
Okay, Henry.
Yeah, okay. So the -18 is equal to a times 1 times 3 times -3, so -9. Which means a equals 2. So our final equation would be y equals 2x squared times x plus 2 times x minus 4. You okay with that? I'm going to try to get this pen cap. Okay. All right, and then looking down here, this is a review of what we learned in the yesterday's or the day before's classwork about standard deviation. So a higher standard deviation is going to go to the value that has a higher spread, or like more spread out data, right? So A is going to be higher because the data has like a wider spread. It goes 10 and then 20, 30, 40, 50. There's like distance, like the distance between all the values in the mean are greater than the second set. And so then we can calculate that. right? So here the mean is equal to 30. So the distances from the mean are 20, 10, 0, 10, and 20. And then here the mean is 32. So the distances are 2, 1, 0, 1, and 2. So then to calculate our standard deviation, we have the square root of 20 squared plus 10 squared plus 0 squared plus 10 squared plus 20 squared, all divided by 5. So that's going to be 800 plus 200, which is 1,000, divided by 5, which is 200. The square root of 200, which will be a number. I don't know what that number is.
Wait, sorry, I can't see it. It's too blurry. Wait, what number was it?
Oh, the square root of 200.
Oh, okay.
Does that help?
Thank you. Sorry.
No worries. Thank you for saying that. And then for B, we're going to have, and I'll calculate that in a moment. We're going to have the square root of 2 squared plus 1 squared plus 0 squared plus 1 squared plus 2 squared.
Wilson.
What am I looking at right now?
Uh,
What is that?
oh, it's background.
Oh, I know, but like, what is it? Okay, whatever. So then dividing by 5, we're going
It's
to
just spaghetti on the ground.
spaghetti. Okay. So then it's 4 plus 1 is 5 plus 1 is 6 plus 4 is 10 divided by 5 is 2. So the square root of 2. So we're basically dealing with the square root of 2 versus the square root of 200. And you can see that indeed this is much higher. The spread is much higher than set B. Cool. What questions do you have?
Cool.